Alright, so let's take a look at your homework, or your test review. We were looking at this question says, a particle moving uniformly along the x-axis is located at 14.8 meters at this time interval and at 3.07 meters at this time interval. Remember that your time is always going to go positive, so the very first, the lower time right here, if you look in at your lower time right here, that will go with this guy. Okay, so this will be your initial xi. And then over here where you see the greater time interval, that will be this guy, which will be xf. So let's move this over here for a second and let's kind of do this whole equation. So remember, all you're trying to figure out is displacement. So the equation for displacement is delta x is equal to xf minus xi. Okay, in this case, delta x will be equal to your xf, which is 307 meters, minus your xi, which is 14.8 meters. Alright, so I should have gotten negative 11.73 meters. Please make sure that you're plugging your numbers in to get this answer. Alright, the next question, and it asks you to find the average velocity. Okay, well, velocity is going to be equal to not final velocity, average velocity. It will be equal to, let's see, xf minus xi, which we've already done, divided by tf minus ti. So in this case, your average velocity will be negative 11.73 meters divided by 4.88 seconds minus 0.665 seconds. Therefore, your velocity will be equal to 4.2 meters per second. And you should have gotten a negative. Negative 4.2 meters per second. Okay, so now this asks you, this is part 3 of that question. So part 3, and it asks you what is the average speed. Remember, speed cannot have you can't have a positive or negative speed. You'll always have a magnitude of speed. It does not a positive or negative, it's just a magnitude. So what that means is whatever your velocity was will be your speed because you went in the same direction. So in this case, if we minimize that over there, we should get, our velocity was this. That means that our speed was 4.2 meters per second. Alright, so we've done these problems on your homework, but now this is just a little bit of review. You've got a plane that is cruising. It has an initial velocity here, then it has an acceleration here. Hold on, let me pull it. It has an acceleration here, and then it has a time here. Okay, so that means we are solving for final velocity. We're going to use the equation VF is equal to VI plus AT. So VF will be 268 meters per second plus your acceleration, which is going to be 16 meters per second squared, times your time of 9.7 seconds. So we find out that, if I kind of reduce this a little bit, we find out that VF is equal to 268 plus 16 times 9.7. We should have got an answer of 423.2 meters. Alright, so now they want to know how far. That's the second part of the question here. So we see there how far. We are looking at through this traveled time. Remember, when you want to know how far, you're going to do the equation XF is equal to XI plus VIT plus 1/2 AT squared. So there is no starting position, so we'll get rid of XI, and then we'll plug in our values VIT 1/2 AT squared. So we will have 268 meters per second, and your time is 9.7 seconds. We're going to add in 1/2 times 16 meters per second squared times 9.7 seconds. So you got to square that. Okay, so when you fill those in, you should get the answer of 3,352.32 meters. We're going to move on to the last question. Okay, in this question it's asking you for the final speed or final velocity. It gives you an initial speed, it gives you an acceleration, and it also gives you a time. So for final velocity, we are going to use the initial, and then we're going to add the acceleration times the time. So VF is equal to 6.38 meters per second plus, do not use 1/2 in this equation, plus your acceleration of 2.1 meters per second squared times your time of 5.2 seconds. So your final velocity will be 0.3 meters per second. Now it also wants you to know to find the displacement, so we're going to use XF. We do not have an initial position, so it goes away. Your initial velocity was 6.38 meters per second. We're going to times that, time your time of 5.2 seconds, and we'll add in 1/2 of the acceleration of 2.1 meters per second squared times the time of 5.2 seconds squared. It should look like this. When you reduce those or bring those down, 6.38 times 5.2 gives you 33.176, and then you add in 0.5 times 2.1 times 5.2 squared, and you get 28.392, and that means that our final answer of the displacement would be equal to 61.568 meters. If you have any questions, please email me or send me a message through Canvas.